Alrighty, welcome back. So we talked about ordered pairs and the fact that we don't want x to repeat in order for it to be a function. We also talked about in a mapping, the easiest way to spot is that you just don't want two arrows going from the same x value. Now, what we're going to talk about is how to tell from a graph. So this first one, we're just going to graph these points, right? And if you forgot how to graph points, x is left to right and y is up and down. So we're going to go -4, so left 4, up 2, and I'm going to put a point there. And if you notice, this Cartwright struggles. So what I'm now going to do is I'm now going to pause my recording. I am going to put all these points on there. So if I were you, pause it, plot these points, and then you can start back up in just a moment. So here I am pausing. You should too. And like magic, my points appeared. Now, also your seriousness, pause and plot these points. So for the -3, I went left 3, up 1. I stayed at the 0 and went down 2. I went left 4, down 1, and then right 1, up 2. That's how I got all my different points. Now that your points are graphed, what we're going to do, the vertical line test is really just to take our vertical lines are our x values, right? Along this vertical line here, any point on this would have an x value of 8, right? So what I am doing with my vertical lines is I am trying to see, do I have any of my vertical lines that have more, in this case, more than 1 point on them? And if any of them do, not just, oh, I have 1, but that's not enough. Nope. If any of my vertical lines, and technically we would be checking every single x value, if any of these vertical lines crossed 2 or more points, it is no longer a function. So when we look at A, this is not a function. And the reason is because where x is -4 has 2 y values. So again, my x cheated on my y. That's the same thing over and over again. So even though we're using a vertical line test is a visual on a graph to say that my x value only has 1 y value. You can't have more than 1 y value. All right, so moving on to B, we need to graph this. So the way I do this is I make a table, T-chart. I plug in x values, I plug in y values. I'm going to choose -2, -1, 0, 1, and 2. I'm just choosing values. And then I plug it in. -2 squared plus 3. So I have a -4 plus 3. And the reason it's -4, -2 squared is 4 times the negative is -4. So that gives me a -1. So I have a -1 here. And then I'm going to do that again. -1 squared plus 3. So I end up with a -1 plus 3, which is 2. I plug in 0, -0 squared plus 3. I end up with 3. I plug in 1, -1 squared plus 3. I end up with a -1 plus 3, which is 2. And I plug in 2, -2 squared plus 3. And I end up with -4 plus 3, which is -1. And so those are my y values. Again, I chose x. I just pulled 5 numbers out of thin air. Chose x. I took 2 to the left of 0, 2 to the right of 0, and went with it. That's all I did. X is not, they're not specific x's. I just chose them. The y values are dependent on those x values. So because of what I chose for x, y is this answer. Just putting that out there. Okay, so now I'm going to graph these. These are my points. -2, -1. Graph. -1, 2. Point. 0, 3. Point. 1, 2. Point, and 2, 3. Point, and then we draw our line, which is, oops, not pretty, but it's there. Okay, so I do my vertical line test, and I check that each of these x values only crosses my line in one spot. And, or not line, my curve because it's technically a parabola. It only touches my curve in one point. And because every x value has exactly one y value, this is a function. So b is a yes. And again, for every x, there is exactly one y. For every x, there is one y. And that is why, whoops, that is why b is a yes. And that's the vertical line test. So again, nothing different from what we did before. If x repeats, it's not a function. And then we just use vertical lines to have a visual on our graph. That's all it is. X cannot repeat. X cannot cheat on y. Okay? That's it. Ms. Carr is done. There is one more video where we're going to talk about function notation and how to evaluate a function, etc. So I will see you there.